Here we've got some metal bars and some cut pieces from those metal bars, 1/2 inch thick here, and one next to it is 1/4 inch thick, 1 inch wide both, and some more pieces cut up here. Digital tachometer here that we're going to measure the speed of this DC motor here, and we've got a couple of meters. And here I've got a battery box that's got 4 small ATV batteries in them, and right here is the box the motor came in, showing its specifications. It's designed, it is a DC motor. It's designed to operate at 24 volts, 3000 RPM, and delivers about 1/3 horsepower at that speed. Going back up here to the battery box here, what I've done is usually I just keep these in parallel, so it just delivers 12 volts. They're very small ATV batteries. But right now I've got the back one and the front one connected in series, so I can get 24 volts to run this particular motor at its designated power input. So let's get started here. One final piece to the puzzle that makes this quite unique, and it's what my friend has termed the Stargate, and it looks like this. Pretty simple, huh? All it is it's 1/8 inch aluminum here and here, plates cut in this shape, and these are thick plastic spacers and brass screws to hold it all together. That's it. It's actually a retainer. The inside diameter here is exactly relative to the diameter of the casing of the motor. Okay, first of all, we'll show you how it runs with its design power input. And on the meter, the voltmeter right now, you can see that it's 25.19 volts. 0 amps right now because we haven't started the motor. We just haven't made the connection, but I will do that and show you what that draws. It's got a lot of torque, so I need to hold it. Okay, there we go. You can see that it's drawing, okay, what's it drawing? It's drawing 0.598. It's dropping down because these batteries are really pulling down. They're not very charged. But usually it's about 0.6 amps. It's running at, let's take a look here, see if you can, I don't know if you can see this. I may have to adjust this a little bit. 3,300, I don't know if that shows up, 3,374 RPM. Now what we're going to do is change it back to 12 volts and see if we can reach the motor's full potential, 3,000 RPM, using 12 volts and far less input power regarding watts. The Stargate, and it simply slips on onto the motor, just slides over the case. And if you notice, I've got some marks on the case here. Let me move this plastic out of the way. I've got some marks on the case here. I don't know if you can see that very well. This is 4, this is A, this is 3. It's in correlation to what we're going to add inside these slots. But the casing of this DC motor is about 1/8 of an inch thick. So what we need, if we just put a magnet on there, the casing wants to deflect the magnetic strength, the flux, outward. And we don't want that. We want it to go inward into the case. So what we do is we come in with a 1/4 of an inch backer, which is heavier than the 1/8 inch, and forces it to reflect inside to those north and south pole magnets on the stator. Now in the retainer I put 2 Neos and 1/4 inch bar steel in each of the large positions, and just one of the small ones in each of the little narrow slot positions. Let's see what it does. check the RPM, 3720, 26, 3730. So it's gaining 3730 at least. Power. The draw is 12.21 volts and 1 amp. On the motor with the Stargate retainer, we've got 2 of the bar magnets in each of the 4 positions, and we've got 8 of the little narrow ones in each of their 4 positions. Let's turn it on. Let's see what the RPM is. Get it on there. 3,500, roughly 3,500 RPM. Goes up and down a little bit. It's drawing 12.34 volts at 1 amp. Now at this point, you would think that if you just added 2 more of these Neo bar magnets to each of the 4 locations for them and filled the stator retainer up, 8 in the position of the small ones and all the way around, and 4 in those positions, that you might double the RPM from where we were just at 3,500 in this condition to say perhaps 7,000 RPM. That's where you would be totally wrong, because what it actually does is it quadruples the speed and gets close to 15,000 RPM. Now this little motor isn't going to run for very long at 15,000 RPM. It's not designed to go but anything but around 3,000 RPM. And the fact that there are no ball bearings on the shaft on either end, just those sleeve bearings, that's where your heat would come in. Because remember, at 3,500 RPM, we were only drawing 12 watts. And at 33 or 3,400 RPM initially, without an enhanced stator magnetic field, that we were drawing 15 watts. So now we're drawing 3 watts less of power and getting a little higher RPM out of this motor with the enhanced field. Now that's at 12 volts. You load this up fully and operate it with the 24 volts, this little motor wants to hit close to 30,000 RPM. Now it can run that fast, but only for a few minutes before it just seizes up just from the heat of this. Because remember, it's still going to draw less power with the enhanced field than it would with raw power coming in. So it's a pretty amazing thing. Okay, here's the final demonstration. We've got we're starting with 12.28 volts on the voltmeter, and the Stargate motor has all 4 of the large bar magnets in place, all in the 4 different locations all the way around, and the 8 small ones in place. So we've got maximum magnetic interaction with the stator field inside, and I've got the digital tach set up to show you what the RPM is. Can't run this for long because I know it'd blow this motor because it just goes crazy. It's just so powerful. But here it goes. So just keep an eye on the tach here, and I'll give it some power. 7,000, 8,000, 9,000, 10,000. Oops, I got to shut it down because it wants to go to 15,000 RPM. Yes, it is spinning. And remember, we're talking about a motor that's only designed to operate at 3,000 RPM. So to have all this less power input and get this kind of output out of it by just enhancing the magnetic field, truly a Stargate operation.